Welcome to our YouTube live session on rapid prototyping in generative AI. I'm Kevin and joined by Justin and Cam from ProLego. All modern software engineering methodologies, whether it's like Agile or Lean Startup, are all designed to mitigate risk. And so in every instance, we want to try to evaluate feasibility quickly before making additional investments. And in generative AI, it's the same process. So when we think about generative AI, we want to try to identify the biggest risks early and try to isolate them. And those risks are the models smart enough? How much data investment is required? And will the solution be useful? So you can begin answering these questions pretty quickly in generative AI because you don't have to build a lot of software to test things because most of the logic is contained in the model itself. And so when we kind of pull back, there's sort of three general steps we go through to isolate those risks and try to answer those questions. And that is do some data prep, run it through the prompts, and then qualitatively sit back and evaluate the results. And what we see on the best performing teams, what we try to do in our projects, is to just rip through these steps as fast as possible. And if you can do it, you should be able to do it in hours or days in most situations to get a preliminary understanding. Are you on the right track, and is this project going to be feasible? Unfortunately, we see a lot of teams who end up wasting a lot of upfront effort doing activities that are more appropriate for scale and process. And so the building user stories and JIRA tickets and architecture diagrams and committees and meetings and configuring tools, and a lot of this is really unnecessary, and you'll make a lot faster progress if you can force yourself to try to evaluate these type of these questions as fast as possible. So we're going to dig into rapid prototyping a little bit today, and we're going to talk about how we're doing it on Project Ground Crew. So Ground Crew is a new AI project we've launched to show our audience how to do a new generative AI project from start to finish. So this is the third video on that episode. The first one we talked about coming up with the idea. This and the second one here. I'm sorry, this is the second video. We're talking about rapid prototyping. So Ground Crew is an LLM RAG over our code base. It's a chat with your code, if you like that analogy, to be able to provide insight, onboard new engineers, and sort of generally manage the code. So let's jump right into things, guys. I can stop sharing the steps in the screen here. See if this works. There we go. How about that view? Tell me a little bit about rapid prototyping with Ground Crew. Like, what did we try and how did it work?
Yeah, so the first thing we did was get an initial data prepared. And we didn't want to spend too much time on that, just, enough to get something going. So the first thing we did was take some other code that we had to extract Python functions from Python files. And so we started with just doing that. So we weren't worried about like classes or scripts, maybe with no functions, or how code interacts with each other. Just let's extract the functions and start testing some prompts using the LLM on that.
Okay, let me jump in for the sake of the audience here, just to kind of pull everything back. So
Sure.
basically, prep the data. What was the data in this instance? The data was
so the data was one of our repositories.
Okay, perfect. Yeah. So we have a repo where we keep a lot of the data we use in the examples for these videos, and that's the repository used. And as I mentioned on the previous YouTube live video, there's a lot of code there, a lot more than I realized because I'm not the one doing the work. And so, so this is a useful application of LLMs for us. And so step one was to start extracting some of not the entire files, but the functions within the files. Is that it? Okay.
Yep. Yeah. I mean, you're not going to put the entire code base into the prompt, right? That's not going to fit. So you have to start extracting pieces in an intelligent manner. And so since we already had functionality to extract functions from Python files, let's just quickest path forward. Let's try that, and then start testing our system on Python functions.
What's an example of a function?
What do you mean? Like from
our code? I know what a function is. I think the audience does too. But I mean, like, what's an example of tell me an example of a function we would have extracted? Just like.
Yeah, I've got some here. So We're looking at like the agent class in NeoSophia, so that had functions such as get the running cost of the LLM or extracting answers from a response, choosing tools, things like that.
Okay, running costs. Let me just, so this is a function that calculates how long it's going to take to run an agent, an LLM agent, and how much it's going to cost in terms of dollars paid to OpenAI. Is that it?
Yeah,
Okay.
monetary cost of the interaction back and
Okay.
forth.
All right. So LLMs, we use OpenAI's API. Every query costs
Mhm.
money. This is a function that predicts how much that's going to cost before you run it.
Correct.
Okay. All right. So you use some code, you extract that, and then what do you do?
Then we just start testing out different prompts to see what we can do with that function. So we can say, okay, ask the LLM, generate a doc string for the function get running cost.
Okay.
Cam,
What's
I think there's
what?
even a step before that that you guys experimented with, because I mean, at first you need to be able to search and retrieve code, right? And so there's the
Yeah,
embedding step, which at first, there's a couple of ways to do that, right? So you could just take the raw code, embed it, and then try to match that against the query, which, correct me if I'm wrong, I think you guys tried, and maybe not surprisingly, wasn't a great result. And so then you guys said, well, how
right.
about we use an LLM to summarize the function, then embed that.
Yep.
And so just real quick, not back of the envelope, but kind of back of the IDE, quick experiments to figure out how to actually get the embeddings to work, right?
Yes. All right.
Yeah,
So
yeah. So
this is. I'm sorry. Go ahead, Justin. So we're getting a great question because this is leading into exactly where I'm going with my questions. And so Diver asked, shouldn't that repository be embedded in a RAG? So yeah, Cam, come on, retrieval augmented generation. You do embeddings. Why aren't you building embeddings? What's this? All this, function extraction crap you guys are doing. What about embeddings? It's a good question.
yeah, it is embedded. We're using ChromaDB for our embedding database. So
Okay.
as Justin was saying, the first thing we tried was taking the function, creating an embedding for that, storing it in the database, and then actually, besides the docstring example, I think the first tool we tried was just asking the LLM, "Hey, can you find a function that does this?" Because sometimes you write a bunch of code, you're like, I know I wrote a function that does X, but I can't remember what it's called. So we said, okay, hey, is there a function that calculates the running cost of the interaction? And so that user's prompt would be embedded, and then we would search the database, comparing embeddings of that user's natural language question with the code that was embedded in the database. And so that's what didn't work too well, because you're comparing an embedding for natural language with an embedding for code.
Okay.
And those
All
are
right.
two
We
very
got to
different
back it
things.
up a bit, Ken, here, because I think we're going to lose the audience. It's okay, because
Sure, sure,
you guys are ripping through this fast and you understand it, but I'm hearing this and it sounds like a software engineering project and not a rapid prototype. The way you're describing it, right? So, but I
Okay.
want to make sure people understand mechanically what you're doing, why you're doing, and how long it takes. Because when you talk about, we've been embedding database embeddings and vectors, like, okay, that's like days of development. Okay, we have to do this and then this and parse documents. Because I mean, on our client projects, we do that. But
Mhm.
characterize, can you characterize, like, give me a sense of like the order, the time, and why you did what you did, just to kind of take a step back and talk to, like, explain to the audience, like this is like days worth of work to do this, or kind of how was it? Break it down for me.
Sure. I think total, just to get an idea, was like a day or two. Like the first day was first extracting, like parsing out the functions from the Python files, storing, like writing the code to store those in the database,
Mm-hmm.
and then just writing a really, really simple like interface where a user could type a question, and then the agent would go and search the database.
Okay.
And I think that was where we were like, it's kind of returning, when we query the database using the user's natural language question, it's kind of returning not great functions. You'd ask for functionality, you'd ask for a certain function, and it would give you different ones, and that's because the embeddings were all embeddings of code.
Okay.
Um, Yeah. And then, so I think the second day is when we're like, okay, why don't we use an LLM to summarize some of these functions? And
Right.
so
Okay.
that was the second day.
Okay. So then let me see if I can summarize that, and you can tell me if I'm wrong. And again, I'm trying to put it like in the context of how you work for the audience. And so you wanted to quickly, we got some data. This is our code. You want to quickly find a way to get that data into an embedding database. In this case, use ChromaDB as the database to store it. So you quickly extracted functions, got the embeddings in the database, and then built a little interface that allow you to ask a question. And when you ask that question, you converted the question to an embedding. You sent I'm sorry.
Yep.
Yeah. Then you did a search between the question embedding and database embedding, and then you found the
and all of
closest
that's
one.
handled by ChromaDB. That is
Oh, it
that is
does.
like a one. Yeah, that's like
Oh, perfect.
one
Okay,
line
so all the
call.
sorry. Okay, so then using ChromaDB, you don't have to cosine similarity code, anything like that. It was already there.
Yeah.
Okay.
All built
okay.
in.
Got it. So this is also why it's quick, because of ChromaDB. Okay. All right. So, so anyway, you found the chunk of code that's closest to it. That's ChromaDB embedding magic, data science magic behind the scene. You send it both to the LLM and say, "Give me an answer," and that was what it did. That was the okay. All right. And this has taken you a day or two because you've done this 50 times, right? So this is, I think in the video I did on this yesterday in our channel, I described, or maybe this is one before that, I described picking the right project for you based on your experience. And so in this case, we had a lot of code. We've done this a lot. So for Cam and Ben to rip this out, we're talking, hours and days, not weeks of work. First time you do this, it takes long. Okay, so all right, so we have some guest named Ben Zimmer, who was the engineer who was doing the work, who unfortunately has a cold, is not joining us today. So Ben wants to weigh in and make sure we're being more precise with what we say. So thank you, Ben, for that. Okay, I think we've described what you did. So why were you doing this particular step? What were you trying to learn, Cam, by doing this, or Justin, either one, or anyone?
Basically, for the first tool that we were trying was just querying a code base, so asking questions about code. And we started with functions because if we ask an LLM a question about a function and it's not able to sort of give us a good answer that we like, then it's not going to be able to do more complicated things like find circular imports or dependency issues, or like, hey, this function affects this function, right? If it can't do like the simple thing first, then we know it probably, it's not guaranteed, but it probably won't be able to do the complicated things.
Okay, and so we're using GPT-4 Turbo, is that right, for this? Okay.
Yeah.
Okay.
I think we started with 3.5 because it was faster.
Okay. All right.
And that could do it. So
okay. So I'm going to make a prediction here, even though I know the answer. So like GPT models are trained on a lot of code. Code, for the most part, looks a lot like language, the way it reads, right? It uses like language words and it has logic to it, verbs, nouns. So I would expect that embeddings of code and embeddings of natural language are fairly easy to find close together. Is that what happened?
No, it's not.
Okay, I'm pointing that out because sometimes when people give the answer for an experiment that didn't work, it's easy to say, well, yeah, it's obvious. Of course, that wouldn't work. But it's not obvious to me, because I would have predicted, because GPT models are trained on a lot of code, that this would work fine. But it did.
Well, the embeddings weren't from GPT.
They're not. Okay. All right.
Yeah, they're sentence embeddings from ChromaDB.
Okay. All right. Okay. Well, then maybe there's a different hypothesis if we used OpenAI's embeddings. Regardless, I think you learn. What did you learn with this fast experiment? Just kind of summarize it for everybody.
That we're not going to be using natural language to search for exact code, like using just embeddings for each of those.
Okay.
We'll want to summarize code into natural language and convert that to an embedding.
Okay, so for every other development team out there that's had the same inspiration we did, that an LLM RAG on our code would be really cool, our experiment showed that embeddings of code and embeddings of natural language don't work very well, at least at ChromaDB. So your mileage may vary, but that was the result of our experiment. Fair to say, or disagree with that?
Yeah, no, that's fair to say. And this is something we talked about going into it, and it was kind of an unknown, but that was sort of the easiest hypothesis to check up front. And so, just embedding the functions directly and seeing if that works. If that works, it'd be great because it'd be super simple. So why don't we start there? Because that's something that's easy to check, and it's maybe 50-50 that would work or less. And so okay, yeah, that doesn't work. So now we are confident that, or we know that that doesn't work. Now we can move on to the next step, which we had kind of already anticipated anyway.
Did you think it would work?
I was curious if it would work. I wasn't sure. I was a little bit skeptical, but if it did work, I would be surprised, and that would be really good to know. And it's the first kind of easy thing to try, so we knocked that out.
Okay, so back to our feasibility questions. You know, are the models smart enough? How much data investment is the solution be useful? We can debate about the models, but it sounds like the big issue was the second bullet, right? Like we had to make some data investment. We had a data set. We wanted to go right into embeddings, and we figured out that wasn't going to work. So we had to try something else. So what did we do next, Cam? What was the inspiration?
I think next was start to flush out the code a little bit more so that we could easily start to prototype new ideas that we had. So yeah, like some of the decisions we made were to kind of make a tools type of interface, such that each new, oh, it'd be cool if it could do this, it could do this. Each of those ideas can then be converted into a tool that our library can use.
Okay, so you built some code to do more rapid experiments. But what of the ideas you have, what was I think you mentioned it before, but I don't want to steal your thunder. But so instead of just doing embeddings of code, you're doing embeddings of
summaries
of the code.
Yeah.
Okay, so you're asking the LLM, what does this function do? It tells you an answer. You make embedding of the answer. Is that it?
No.
Oh.
Or what do you mean?
You asking the LLM to summarize what the Python functions do.
Oh, right.
Okay.
I see. So the what does this function do can also be a user prompt to the system itself.
Okay. Right.
So that's what I thought.
I'm sorry. Yeah, no, I'm speaking procedurally, not in terms of the solution. Okay.
Yeah. So to summarize the code, we just have a basic prompt that says like your task is to generate a concise summary of the Python code, and then we have some constraints on it, like limit it to 5 sentences or less, so we get a consistent summary across different chunks of code.
Okay.
So then those summaries we store in the database. And so when a user asks a question about some of the code, the question, which is then converted to an embedding, is then compared with the embeddings of the summaries. And matching up two natural language embeddings converted from natural language is better than one natural language and one from code.
Okay. Do you have the prompts that you use to make those summaries handy? I'm just gonna maybe.
Yeah, I can read it if you'd like.
You could do screen share, or is it in? Can you do? Let me stop screen sharing. You could do it. If it's not handy, man, I could maybe dig it up as well.
I actually have it right here.
Okay.
Oh, you do?
Go right ahead, Justin.
All right, I will. First time I've shared. There it is. Okay. All right, can you guys see that?
No, because I gotta bring it up on the screen here. How's that? Did that work? Wait, I gotta add the stage. There we go. Somewhat there. Yeah, that's better. Okay.
Okay, so here's I think what Cam was just describing. Does that summarize?
Yep.
Is that it?
Yep.
So we actually have a file of all the different prompts that we're developing and using in this system. And so here's the summarized code prompt. And as Cam was saying, we're telling the LLM that its task is to generate a concise summary of the Python code, which we've extracted, and we give it along with this prompt. And as Cam just said, so keep your summary to 5 sentences or less, and include these important aspects in the summary, like relevant information from comments and doc strings, dependencies, imports, things like that.
Mm-hmm. Excellent.
And so
Go ahead, Cam.
One thing to note here is you see it says generate a concise summary of the above Python code. And so something that we haven't rigorously tested, but just a general trend that I've seen is putting the instructions for the LLM at the very bottom works better than if we said your task is to generate a concise summary of the below Python code and then put all the Python code below the task.
Really?
So having, yeah.
I do it the exact opposite. Like I say, your job is to X, Y, Z, and I paste in the code. I mean, so you find put in the data and then said oh, wow.
Yeah, I found it works better that way.
Is that because the LLMs are better at paying attention of the first stuff in their context? What's the hypothesis there?
Honestly, I'm not too sure.
Dr. Pounders, any theories?
No, I mean, I think it's something that we just learn by trial and error. I don't know if there's any systematic logic to it.
All right, Ben is probably now sitting there thinking and typing and going to type in something. I'll share on the screen here in a moment. Okay, well that was useful for me to see because well, there's a couple of things. Every time I see what you guys are doing with generative AI, I'm always shocked at how little like code there is. But at the same time, I know that even though there's like Ben doesn't know either. All right, so we don't know why we found that to be the case, and we don't know. Maybe others have maybe somebody else listening to has a theory. If so, please help make the rest of us smarter. So like 5 sentences on how to do that. You had to. That's like testing different ideas to see what works. Is that correct? I mean, you're like 5 sentences, not 6, not 4, not 10, not 12, and you want to like tell it what to do. Those prompts you're writing initially based on experience, but then you're also testing them quickly to see what works well. Is that correct?
Yeah, we didn't try like 2 sentences versus 10 sentences. We just saw that when we initially put in a prompt that didn't say anything about how long it should be, and it was like this huge summary.
Yeah.
Okay, that's too big. Overly verbose, it wasn't really a summary. So then we just decided, okay, 5 seems good for now, and if we find that it's not appropriate, then we'll test out different ones later.
Yeah, this is so I want to just maybe point this out for a lot of people who've come up through software engineering environments where you were very like process and rigorous and rigid so that you could have, predictability for how you're going to build things out. What you're talking about doing with this rapid prototype is just slinging stuff out there as fast as you can and changing it to see if you can get a good direction. And that's not the way a lot of developers are used to working, especially if they're coming from an environment where they're defining functions and user stories in your task. So you're going to build that one and then test it, then integrate it. And build, like software engineering can be very methodical. I mean, still, of course, all program takes creativity. But in this case, the tool's so powerful. And you had the ways of solving it are so open-ended. You can quickly start ripping through ideas and see, are we heading in the right direction? And it's just a very different way of working than I was trained to do for most of my career.
Well, I think it's really important to do the rapid prototyping because the technology is also so new. So if you're adding a feature to a database or a new type of database interaction, or just adding an API on top of existing functionality, all that stuff is very predictable. And most software engineers who have some experience have probably done that before, whether it's the API or the database interaction, whatever that might be. But with GPT-4, there's a lot of, or any of these LLMs, there's a lot of unknowns. So, I mean, how are the embeddings exactly going to work? As Cam just mentioned too, we put the instructions at the top to the bottom. There's so many unknowns because the technology is not even a year old and everybody's still exploring the space, that it's really important to build in, actually I think it's the point of today's conversation, is to build in the time to do these quick experiments. Try that, didn't work, okay. Add, this instruction, okay, that worked. Just gotta feel your way through the first parts of the development process to see what's feasible, what's working well, what seems to not be working well, or challenges that you didn't expect.
I think also this is what people don't really understand about this who haven't done it is like, and you guys will read this sometimes too. It's like, well, program is going to go away because with, LLMs, you're just writing language and everyone can write language. It's like the same mindset of how do you break things down and do experiments and evaluate and look results and what's happening under the scene. All of that is still true. And that, that mindset is what people either love or absolutely hate about programming. I mean, this is first time I took a programming class when I was like 12 or 13 years old. I quickly realized there was a lot of people in my class who did not like thinking like this and just want to know the answer. Anyway, I'm curious if you guys have any observations or opinions on that.
I don't think this is getting rid of programmers anytime soon. But the challenge is, I think you're a little bit different. I mean, instead of just writing code, we may have used this analogy in the past, but it's almost like bringing somebody new onto your team. Maybe it's an intern, they have some amount of experience. And so you have to establish, how am I going to communicate with this person? If you ask them to do a task and they mess it up, okay, well, did I not ask clearly, or do they not have the ability to do this task? It almost feels more like building, this is too grandiose, not a relationship with a person, but establishing a mode of communication with somebody that has their own distinct communication style. And
completely. Yeah. What I find, I don't know if this is probably not popular, and I guess I wouldn't, but what I've actually done is actually gotten mad at the LLM. Like, no, that was a terrible answer. Do it again. And I get better answers, right? Like I would never speak to a person that way, but like, that's terrible. And it triggers some deeper layer in the neural network that goes, oh, I got to go back and think harder about this.
Yeah.
Anyway, it's just like the parents that have Siri in their house and their kids start being impolite to Siri, and they've got to retrain the kids to be nicer to Siri because they're worried they're going to take it out to public, right? So, all right, I'm rambling and getting off topic here a bit. So I think for the purposes, as we covered the main ideas. We talked a little bit about how you guys are doing it. I think the audience will get it. Anything else that we should maybe talk about? Like advice for companies that are teams doing this for the first time. How should they think about it? How is it different than traditional programming? What do you have to offer?
Well, something we did, as you mentioned at the beginning, we didn't, write user stories or plan a JIRA board or anything like that. But we did spend an hour, maybe an hour and a half before we started this rapid prototyping process, saying, just making sure that the three of us were on the same page. This is what we want to do. And in the end, we would like to be able to answer these questions. We wrote down like half a dozen different questions that we would like the system to be able to answer. And then once we were all on the same page, we had a list of examples, and we kind of started with the simple one. We'll see if we can do that. And then that made sure that we were at least directionally, kind of doing experiments that would lead to the outcome that we all wanted to see.
I guess that's important to point out that in this case, we're doing something that is that we've never seen done before. I know that other people are thinking about it, working on. We have never seen a working solution, so we had to kind of push some new ground. And then, did you try any open source model instead of open AI?
Not yet, but we're building things generally such that we should be able to just plug in different open source models.
So it's on our to-do list. Well, this is this is great, guys. So what can we expect to talk about in future episodes of our step-by-step series on Ground Crew? What do you think is what are we gonna, since you guys are now we've got a little bit of time warp here. Rapid prototyping was 2 weeks ago, and my ability to make content is finally catching up. So what after rapid prototyping, what do you think is going to happen?
Well, I think we could demo something. We could start to actually, we could show what we've done so far. We could talk about challenges that have come across, that we've come across in development. Kind of once we get the rapid prototyping done, then it's kind of establish feasibility. Okay, so there's something here that's going to work.
Okay.
So how do you set the project up to be successful over the near and the longer term? The kind of trade-offs that we're thinking about, and how do we set up the foundation now that we know that it's a feasible project.
Awesome. Okay, so maybe that'll be our next video. We'll kind of start digging into a little more nuts and bolts. We'll shift some screens, some code, talk about evaluation frameworks and how it's actually working. Awesome. Guys, this was fantastic. I learned a bunch of new stuff. Thanks, everybody, for joining us, and we will see you next week at the same time. Take care.
Thanks.